Thank you everyone for coming down this Sunday afternoon. I'm going to start introducing myself. I'm Tejas. I'm an architect myself first, moved into material systems right now. While I focus more on scale and scalability in the entire presentation, I would start with, say, migration and how nature really does that. How do we really look at migration in nature? You would have looked at this bird, right? And then they migrate from one part of the world to the other part of the world. How does this really happen? There's a leader bird right in the center over there at the top, and then it makes this V form, right? And that's because the other birds that are there behind, they get lower draft of the wind, so the energy consumption is lower. That is why they are able to migrate from one part of this world to the other part as well. Moving from this context, we'll come back to this later. What we do is, the larger vision of the company is to make carbon negative homes. But the question is, are we really building it like that? That's how we're really building. That's an aerial image of Delhi. It's very difficult to spot even a tree in this because we're building the size of New York every month. And that adds to about 11% of the energy-related carbon emissions, and that is because we use energy-intensive methods of manufacturing right now, which is what creates air pollution, by the way. And air pollution essentially has two issues. One is, how do you capture or collect it? Second, what do you really do with it? We are in the carbon utilization space, which means that we take carbon from various factories and partners, and then we make valuable products out of that. How do we really do that? We take the carbon from tire recycling factories. We see this tire, the end of life cycle of this tire is it goes into recycling, then into also generating 150 million kgs of waste. What happens to all of this? It's then burnt in factories, which is what creates air pollution. We want to prevent this from happening at the first place and give it a use case scenario. We take these, which are then stored in these bags and then burnt. We mix that with other industrial waste, and we made our first flagship product, which is a tile. How do we do that? We have a 4-stage proprietary process. We collect the carbon. We process this carbon. We work with a DAC partner, which is direct air capture a partner. So the CO2 is captured directly from the air. It goes into a silo. We work with a 200-year-old craft where it gets compressed. And then we put that into a reactor, which is what we are building right now, where the CO2 gets converted into carbonates in the tiles and gets stored to form any plain, pattern, or customizable tiles with that. It's available in plain, pattern, various sizes, and designs as well. Unique features, we use only 1/5 of the energy. It prevents 15 minutes of diesel car pollution. We use about 70% of upcycled materials, and it's absolutely handcrafted as we start with that. We've gone through various certifications for LEED certified buildings, IGBC, and it's aligned to SDG goals as well. Why is it game changing? Is because it's the only carbon negative tile, which means that it stores more carbon net than what it really emits. Most of you will go back to your rooms right now, which would most likely have a vitrified tile, which is the last one, which is 8 times more carbon intensive than what our tile is right now. It's available in plain, in pattern for your wall tiles as well. We've used in various stores by now, available in pattern as well. We've also applied this with stores in Adidas across India by now, which also right now offsets 1 ton of emissions as well. In the center, you see that's the Adidas logo. So it gives scope for brand collaborations as well. How do we scale? We started with this question, right? So we collect this waste, we process this, we compress this in a machine, and then we put that into a reactor. On the other end, we work with a DAC partner, direct air capture partner. It goes into a silo and then into a reactor to form any CO2 cured building material. So we are looking to build 10 million square feet of this in the next 4 years. That's the scale in which we are looking at. Coming back to our vision of 1 million carbon negative homes, essentially we've already prevented 10 tons. We're now moving into 500 tons with our demo plant, and then literally to 100 million tons of CO2 emissions prevented and avoided through the building material that we are really building. Again, coming back to the clean air and the bird and the V formation, the interesting bit is not this. The interesting bit is really the leader bird gets to go back and rest, which means that everyone gets a chance to be a leader bird here. It's not only one's responsibility. This is conscious collective, which means we need to act as a collective. Everyone needs to do this. So this is what really happens. And then I want to end with this, that if you want to really go fast, go alone. But if you want to go far, we all need to go together. We need to migrate from this high intensive way of manufacturing to a low intensive way of building, and we can do that only if we act together. Thank you.